Well, for the next problem in our review, we have to solve a system of 3 equations. And if you remember, what we have to do is take 2 equations and eliminate one of the variables. And then that would give us an equation with only 2 variables. And I think I'm going to get rid of the x's with equation 1 and 2. So I could effectively subtract equation 2 from equation 1 and the x would drop out. That'll give us an equation with just a y and a z. Then I'll use equation 1 and 3 to eliminate the x, and that'll give us a second equation with just a y and a z. Then we'll solve the 2 equations with 2 unknowns just like we did in the previous video, and then we'll continue from there. So I'm going to call this 1, 2, and 3. So I'm going to write down equation number 1, and I'm going to write -1 times equation number 2 underneath it. So equation number 1 is x plus 2y minus z equals 3, just like it is. Now I'm going to multiply this by -1 to get a negative x here. So negative x minus 3y plus z equals -4. Well, this one might actually work out better than expected. Notice what's going to happen when we add the equations together. The x's get knocked out, cancel out, and so do the z's. So we end up getting a -y equals -1, or y equals 1. So we're 1/3 of the way done. We're going to get an ordered triple, an x, y, and a z, and we've already determined that the y value is a 1. All right, well, let's proceed as we stated. I'm going to write down equation number 1 again. X plus 2y minus z equals 3. Ah, rats, I need to multiply that one by -2. -2 because I want this to be a -2x to cancel out with this 2x when we add them together. So I need -2 times equation number 1. So it's going to be -2x minus 4y, and then -2 would make that a +2. And then times -2 would make this a -6. Sorry, it's so messy. Maybe I'll rewrite that. -2 times 1, equation number 1, is -2x minus 4y plus 2z equals -6. That's a little better. All right, underneath that, I'm just going to write equation number 3 as it is, which starts with 2x minus 2y plus 2z equals 8. And now, because we multiplied equation number 1 by -2, those x's are going to cancel out. And we get -6y plus 4z equals, add those and we get a 2. All right, so between this equation and this equation, since 2 of them dropped out, it's an equation in only one variable, which told us that y is equal to 1. So we know y is equal to 1. So by combining these two, I know I get -6 times 1, which is -6, plus 4z equals 2. So if I add 6 to both sides, I get 4z equals, add 6 gives me an 8, so z is equal to 2, because I divide both sides by 4 here. All right, so z we know is a 2. 2, not a z. Okay, remember that's at number 2. 1 there, 2, y is 1, z is 2. And now we need to go up and figure out what x is. Let's look at equation number 1 and plug in y equals 1 and z equals 2 and see what happens. Equation 1 gives us x plus 2 times 1 minus z, which is minus 2, equals 3. So x plus 2 minus 2 just cancel out. So x equals 3. Now let's see. I'm going to double check. I really want this answer to be correct. So let's look at, we plugged in equation number 1 already. Let's verify that it works in equation 2 and 3. If x is 3, this is equation 2 now. 3 plus 3 times 1 minus 2 equals 4. Is that true? 3 plus 3 is 6, minus 2 equals 4. Works there. Number 3. 2 times 3, let's see if it works. 2 times 3 minus 2 times 1 plus 2 times 2 equals 8. Is that true? 6 minus 2 plus 4, that's 10 minus 2 is 8. That works. So now I know that 3, 1, 2 is correct, or x equals 3, y equals 1, z equals 2. All right. Changing types of problems here. We're going to graph the solutions to these two inequalities. This one and this one. This one's actually easier. Remember what we do. We replace the inequality with an equal sign and draw the line. And then we have to decide whether to shade the upper half plane or lower half plane. And the easiest way to do this is just solve it for y. Get y by itself on one side. So 4y minus 6x plus 16. 4y equals negative 6x plus 16. Sorry about that. It looks, I've got 3 lines. It's 4y equals negative 6x plus 16. And then we divide everything by 4 to get y equals negative 3 over 2x plus 4. I divided everything by 4. 6 over 4 is 3 halves. That's where this came from. Negative 6 over 4 is negative 3 halves. And then 16 divided by 4 is 4. All right, well this, and goodness, I shouldn't have put an equal. It's a less than. So y is less than this. So this tells us two things. The strict less than means we're going to use a dashed line instead of a solid line. And the y less than tells us it's a lower half plane that we shade. All right, so this is all we need to get this done. Y-intercept is 4. So 1, 2, 3, 4, that point. And the slope is negative 3 over 2, which means down 3 to the right 2. Go down 3 to the right 2. Down 3 to the right 2. So dashed line. Like so. And then the lower half plane. So it's going to look like this. So this shaded region, it's unbounded because we need these arrows. It goes on infinitely in that direction. Think of this line as cutting the xy plane into two half planes, up here and down here. And the solution is all these ordered pairs in the lower half plane. Okay? Well, this one is the interesting one because there's no y in it. So we're really going to get a vertical line. The vertical line will be x equals negative 3, and we're going to make it solid. And we don't have an upper half plane or a lower half plane on a vertical line. We have a left and a right. And this is x less than or equal. So we're going to do the left half plane. So let's graph the line. The vertical line, x equals negative 3. Here's 0. Negative 1, negative 2, negative 3. So that's the vertical line. And we're doing the left half of that. So we're not going to shade anything on the right. We're going to shade all of this. Like so.